Happy to have you on the podcast.
Oh, thanks, man.
Can you quickly introduce yourself to the audience?
My name's Lars Klint. I'm a technical instructor for a company called The Cloud Guru, and I do Azure instructional videos or courses for anything Azure, really. And I'm also a Microsoft MVP for the Windows Platform Development category. And I do a bunch of mixed reality and car-related stuff as well. Yeah, I've written an ebook for Sync Fusion on HoloLens development. And I've also I've written many articles and done other video courses for Pluralsight, and I'll probably leave something out because I always forget a few bits, but a few things in the IT space here and there, and whatever I find interesting.
Can you tell us a bit about Azure DevOps?
I've done a couple of courses on Azure DevOps, or it's what used to be called Visual Studio Team Services, or VSTS. So it's now been rebranded or renamed to Azure DevOps. It's a collection of tools. It's a collection of products where you can use one or any or all of them if you want. There's a boards component, which is for managing all of your, if you do any kind of agile development, so your Kanban boards or your workflow management, that sort of stuff. You can have a project manager that manages all the tasks for you in your project, and you can set up sprints and have a backlog and whatever else you need to do in an agile development process. It has a code repository. So similar to what GitHub is, it has a way of storing your source code and versioning it and using Git in the same way that GitHub uses Git. So you can use it for that as well, to push all of your code up to Azure DevOps. And then it has a few other features that most people don't really know about unless they use it every day. So the boards and the repos are kind of self-explanatory. They're very common pieces that people are using. But you can also set up build pipelines, which I find very, very cool. And build pipelines in this case is... it's a way of setting up automation generally in a continuous integration or continuous development way, and it allows you to use the code that you either have in Azure DevOps in your repos, or have it in GitHub, or anywhere else, Bitbucket, wherever you use your source control can be used. And continuous integration is a way of every time someone pushes code into that repository, it builds the code, for example, and it performs all the tests that are on it, and it may push it to a server if it is successfully built, and it may do other actions based on that. There's a whole bunch of different actions and events that you can do in a pipeline, and then it also comes with test plans, which is a way of managing all your tests, and it comes with artifacts, which is a way of having your own package manager, kind of like NuGet or Maven if you're a Java developer. So it's kind of, that was the really, really quick overview of a ton of features that are in this product. So it's it does a lot more, but that's sort of my best overview.
Yeah, let's break down some of the phases. In
Sure.
the DevOps phases, we have plan for a start point, where we get the requirement from the client. Here you can use Azure boards. You can have work item codes, and then those work item codes can have user stories. And finally, in Azure Sprint, you can create tasks for each user stories. Is that right?
Yeah, that's pretty much it. There's a lot of different ways that people work with these tools. And I guess Microsoft in this case has tried to not accommodate all of them, but at least cover the main or sort of the normal ways or most popular ways that people use these tools. So yes, work items is where you would, if you're planning a session on a product and you're saying I need to develop these 6 features, then you may break them down into say 30 work items, and you would put them in there. And then they would go on a board, so you can manage the process of whether they're being developed, whether they're done, whether they're in QA or whatever status they might have. And you can put them into sprints, where a sprint is part of the agile development methodology, where you select a group of work items that you I guess, realistically believe that you can finish in a set period of time. Generally, it's about 2 weeks. A lot of people do 2-week sprints, but you could also do 1-week sprints or a month-long sprint. And you can manage that whole workflow in the single, in one tool in Azure DevOps, which is kind of cool.
The board, is it well integrated? For example, you mentioned that there are Azure test plans. For example, if I done a integration test and it is successful, it is complete. And I had a task on the Azure sprint, which was to do a test for that specific test. Can it be automatically complete, or you should go there and check the box that is complete?
It really can be either way. All of these tools, or the products, so the boards, the repos, the pipelines, the test plans, and the artifacts, can be used on their own, or they integrate fully all of them as well. So you could have an artifacts implementation, so you have your own repository of packages, and you can have your pipeline draw those packages from your artifacts and execute a test plan at the same time in the build pipeline and have events based on that. So you can either do it manually, or you can automatically set it up with scripts and pipelines as well. It really is whatever suits your workflow and your organization.
When you say scripts, we can write PowerShell scripts on that, or?
Yeah, PowerShell scripts. You can do Bash scripts. You can set up build scripts, which is could be PowerShell scripts as well. It really is, if you can find a tool that will execute your script. It could be an Ant script for build purposes as well, I believe. So there's a bunch of different ways that you can script things. But when I say scripting, I'm just sort of referring to a way of automating things. So you can script a process, meaning you can outline a bunch of steps. Actually, the latest and the most the way that Microsoft is pushing things being scripted right now is using a YAML template. And YAML is a declarative language that you declare what you want out of it, not exactly how it does it. And that seems to be a very popular way of doing build scripts, for example. So it's all changing, and we're trying to accommodate everything, I guess. And Microsoft is doing a reasonably good job at it.
The next phase is coding. So you mentioned that there is a source control management. For example, Git, they can commit push to Git branches which are on the Azure DevOps itself. Is that right? On source control?
Yeah, definitely. Yeah. Repository is a source control implementation that if you want to use it, it is there. If you're more comfortable using GitHub, you can use GitHub as well, and you just draw the code in from there. But repos is the built-in implementation in Azure DevOps for managing source code in a repository way. So it uses Git generally. If you really want to, be pain, if you really want to cause yourself pain, you can also use Visual Source Safe, or whatever the old school way of doing source control is as well. But please don't, if you ever consider that.
Yeah, that was difficult. Okay, so the next phase is the build lifecycle. So this has multiple steps in it. For example, there's validation, compilation, packaging, and then testing, unit testing, and integrated testing. I had some friends that were using some build tools. I'll give you some examples. We have Jenkins 2.0, Travis CI, CodeShip, Bamboo, Gradle. Does Azure have its own build tool, or?
So you can set up a build tool in whatever way you want. If you want to use Azure DevOps, you can. It uses, I'm not 100% sure. I think it uses MS Build. At least it can do it if you're building .NET. If the thing is that Azure DevOps builds whatever code you like. So if you're a Ruby developer or if you're a Java developer, you can use it as well. And then you use whatever build tool that goes with that language. Of course, you wouldn't use a .NET build tool if you were a Ruby developer. That kind of wouldn't make any sense. But if you're a .NET developer, there are a ton of different build tools you can use there as well. So it really depends on what your programming language of choice is.
Right, Azure have test plans, as we were saying. Tests can be configurable for various web browsers, and even mobile apps have found. It can do load test and stress testing. And you can also review your previous tests. Is there anything else about Azure Test Planner?
It's like the other products here as well. If you have a way of scripting a test, so a test in general is just running some code and looking at the output. That's pretty much what a test is. And based on what that output is, you might do a thing. You might have an action to that event. A test plan is just a bunch of tests that you set up, and you can then have common parameters. You can have common configuration settings that you use. And again, you can load test it, which is one of the benefits of having a cloud solution is that if you're testing stuff locally, it can be hard to simulate, say, if you had 10,000 users at the same time on your website. But when you use a cloud solution like Azure DevOps, where all that is managed for you, you can have a load test that says, hey, what happens if 10,000 users at the same time request the front page of my site or something like that? So there are definite benefits to using a cloud solution, such as Azure DevOps, for doing testing. Absolutely.
Great. That is a good feature. Integration. This is the next step. I know that for integration there are tools such as Jenkins, which integrate various stages of DevOps. They allow for continuous deployment. That is, the moment a dev made a change in the repo, Jenkins will pull that code and prepare a build. Once the build lifecycle is complete, then it will deploy to a production server for release. How does it work with Azure DevOps? Is it a similar process?
I think what you're describing is kind of a build pipeline as well, where you define a whole flow of what happens whenever someone checks in code or whenever an event happens. If a notification goes out to a mobile device or something, you can trigger different things. And the other side of there's continuous integration, which is in my opinion that is the least you need. So every time someone checks in code, everything is built, everything is tested, and it is pushed to generally a staging server. So whatever is the latest in development will be visible somewhere. It also means that things fail really quick. So if there's something that is not correct or something is broken, you'll find out really quick. And as you said, the other side of this, or the extension of it, is continuous deployment, which is a whole other level of, configuration and trust in your build pipeline, that you continuously deploy your code or your solution to production generally. So there's two sides of that coin, and they're both very important. But I would say continuous integration is almost as definite in modern software development.
I agree. Continuous deployment is a bit risky also, I think, especially if you're directly going to deploy your code on production. It's quite risky.
It can be. Depends on what kind of gates and what kind of, checks and balances you have in place. Because it's ideally if your continuous integration is correct in terms of doing and not blowing up. I mean, obviously business logic is always more tricky to test for because something may have been misunderstood and implemented the wrong way. But the continuous deployment, if you trust the continuous integration and you get comfortable with that, the continuous deployment is not as big a step as you might think. But you agree, yeah, you're right. It is a bit daunting suddenly going, yeah, we just deploy it automatically into production, right?
Talking about deployment, I've been using Docker actually. It allows a developer to write a project in a Docker file. Once that Docker file is written, an image can be built from that. Then the Docker image is uploaded to the Docker Hub, which is a Git repository of Docker images. And then via that Docker Hub, teams can pull that Docker image and replicate the developer environment in the production environment. Now my question is, does Azure DevOps also use Docker?
You can definitely use Docker. You can set up your build pipeline to have a Docker component. So a containerization of an app is kind of another level. It's really, really useful if you're concerned about versioning, if you're concerned about making everything kind of deployable in one go. for a standard smaller website, it's probably overkill, but you could have Docker image for development so that you get developers up and running real quick. You can have one for staging. You can have one that you push to production, and you can certainly set all of that up in Azure DevOps in your pipeline. Yeah, definitely.
Great. So we've been talking about the CI/CD pipeline, continuous integration. We talked about how a developer can commit code and then the build is made, it is tested. Then we talk about continuous delivery, automatically deploying the build to a test environment where UAT tests can be done, user acceptance tests. And then there's also continuous deployment, which we talk about, which is an app going to production automatically. Now, I would like to talk about Azure Apps.
Sure.
There is a Azure App Service, and then there is a Azure Service Plan, which is like a computer in the cloud. The App Service Plan for a VM can be set with an amount of memory and RAM. It can be a specific amount, and then it can be scaled as per your needs. You can create n number of apps on an app service. So is this right? You can create any amount of apps you want on an app service plan?
Yes, your app service plan, as you say, it's almost like your own virtual machine, except the difference is that you don't manage the maintenance of it. You don't manage the setup and the I guess the machine itself, but you do define how much power, what the hardware looks like. So obviously this is all virtualization, and then Azure will provision this for you. So then you have the app service plan. Now with app services, you're absolutely right. You can have app services connected. You can have multiple app services connected to an app service plan. Generally, you can do that. Depends on kind of how you use them. I would almost have an app service plan per app service probably, because it makes it easier to manage in terms of scaling and everything. I think it really depends on how you're using it, I think. But yeah, you're right. You can have multiple app services. You can have multiple app services on an app service plan. Well, there's a lot of app service words here. So, but it's an easy way of making a website and having it scale up and scale out. You can set up more servers and everything. So.
Right. Talking about websites, there's also the cloud platform that allows you to build web apps and mobile apps. Web apps can be deployed IIS on the cloud itself. There's a load balancer with a sticky sessions as set by default. Those web apps can be either ASP.NET Core, ASP.NET MVC, and even WordPress. Is there any other kind of web app that can be deployed?
Oh yeah, there's a ton. If you go into the Azure portal, or use the command line interface, the Azure CLI, you add a new app service. There's a ton of templates. I've got a few WordPress sites. I've got an app service that runs a ASP.NET Core MVC app. I've got an ASP.NET Core standard app. I mean, it's all different kind of frameworks, but you can set up an Orchard CMS if you like that. You can have a LAMP stack. You can have PHP. There's really no limit to what you can run on it. You can have a Windows machine, you can have a Linux machine, and it's very powerful, and it lets you create content rather than having to manage platforms, which is nice when you're a developer.
Yes, that is great, especially having a Linux machine, and you can work with various open source programming languages there. And I found that many of my friends who develop Django apps are going for the Linux option.
Yep, and generally the Linux option is cheaper as well to run, so there's lots of benefits in doing that too. I can't remember what the numbers are, but it's something like now, we're recording this in November 2018, it's something like 40% of Azure instances are Linux-based or something like that. It's a very, very large amount.
It also supports DBs, databases such as MySQL, SQL Server, and it has firewall settings to ensure the security. There's also Azure mobile apps, so you can create your mobile app with features such as single sign-on, cross-platform push notification, offline data sync. Those apps can even be on the C# side with Xamarin. Is there anything else, Android?
Oh yeah, there's tons of stuff. And it's impossible to know everything on Azure. It's just, there's so much new all the time as well.
And there's also support for old app using logic apps and API apps with Azure.
Yeah, they're different beasts. Logic apps are more, as the name says, you basically, it's like a puzzle. You put together a workflow of, if this happens, then do this. If that happens, then do that. And they're incredibly powerful to work in conjunction with Azure Functions. So if you're into the serverless space, using an Azure function to trigger something based on a logic app, or having a trigger a function, either way is really powerful. So there's so many scenarios here though.
We mentioned about pricing. There's also the Azure pricing option with pay as you go, which is pay per minute of usage, right?
Mm-hmm. Yeah, and there is a free tier as well. You can, if if you're just yourself, I can't remember how much it is, but there's a free tier where you don't pay for a little bit of resources. I guess I can't remember exactly how much it is. But if you are a business or a startup, you can apply for something called BizSpark, and that gives you some number of dollars to use on Azure every month. Or there's enterprise subscriptions, or you can get MSDN subscriptions that allows you to use Azure. And there's a whole bunch of ways that you can find a way that makes sense in however way your business wants to use cloud services. If you do it the right way, Azure compute time is very, very cost effective.
I was really happy to have you, and you are welcome to come on the podcast again in the future.
Thanks a lot, Rishi. Thanks for your time. Appreciate being on it.